So in the previous video we were discussing about the K-maps. So let us try to solve more questions related to K-maps and let us try to identify more properties related to K-maps. Okay. So assume we have this particular function. So the function is of three variables a, b and c. A, b and c, and assume this is the function f. So the combination of a, b and c will be 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. So assume we have these combinations. Okay, and assume the value of the function is 0, 1, 1, 1, 0, 1, 0, 1. Assume we have this particular function. Okay, so for this we are going to make a K-map. So this is a function with three variables, therefore this will be the K-map for this. This will be the K-map. This is A, this is BC. Okay, see, it matters what you are writing here. How you are, if you are writing A here and BC here, it matters. If you write AB here and C here, that also matters. I will discuss about it at a later point of time. So assume we have A and BC, and assume this is 0, 0, 0, 1, 1, 1, 1, 0, and this is 0 and 1. So I discussed in the previous videos why we are using this, because this is a cyclic code, and in cyclic codes for adjacent two cells we have change of only one variable. Okay, and for this particular function, we have one values at 0, 0, 0. That means 0, 0, 1. So this is 0, 0, 1. So it is 0, 0, 1. So it is 1. Okay. Again, we have one value at 0, 1, 0, 1. 0, 1, 0. At this case, we have 1. Again, we have one value at 0, 1, 1. So it is 0, 1, 1. So we have 1. Next, we have one at 1, 0, 1. So this is 1 and this is 0, 1. So we have 1 at this location, and we have 1 at 1, 1, 1. So this is 1 at this location. Okay. So this is a K-map. Now in this particular K-map, how many subcubes can be there? See, what is a subcube? We say a collection of 2 raised to power m cells, each adjacent to m cells of collection is called a subcube. What do I mean to say is, we can have a subcube of size 2 raised to power 0, where m is equal to 0 of size 1. We can have a subcube of size 2 if m is equal to 1, so of size 2. We can have a subcube of size 4. We can have a subcube of size 8 and so on, where this power is showing m. Right. So what do I mean to say is, assume for this particular diagram, this creates a subcube, 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 as well as this one, this biggest one creates a subcube, as well as the biggest one also creates a subcube. Okay, so let me make these subcubes. See, we say this is 2 raised to power m cells, each adjacent to m cells of collection is called a subcube. What do I mean to say? What do I mean to say is, assume this is the K-map, this is the K-map, this is A, this is BC, 0, 0, 0, 1, 1, 1, 1, 0, 0 and 1. For this particular function, this is the K-map, and in this particular K-map, if you take this subcube, then the size of this subcube is 2. That means 2 raised to power 1, which is equal to 2. Therefore, the value of m is 1. So how I am taking this? This is from the first line. The collection of 2 raised to power m cells, each adjacent to m cells of collection is called a subcube. So here, if you take this particular subcube, the size of this subcube is 2, and because the size is 2, therefore the value of m is 1. And what do I mean to say the value of m is 1? That means these two subcubes are adjacent to one subcube. These two subcubes are adjacent to one. These two are adjacent. But if I make a subcube like this, the size of this particular subcube is 2 raised to power 2, which is equal to 4. 2 raised to power 2, which is equal to 4. Therefore, the value of m will become 2. Hence you can clearly see for every subcube, for every cube, this particular cube, it's adjacent to this and adjacent to this. In the same way, this particular subcube is this particular cube or cell is adjacent to this and adjacent to this. These are cells. Okay, this complete is a cell. Okay, so for in this bigger subcube, every cell is adjacent to two cells. Every cell is adjacent to two cells. Right, so if you make a subcube of size 2, then every cell is adjacent to one cell. If you make a subcube of size 4, then every cell is adjacent to two cells, because 2 raised to power 2 is 4, therefore the value of m will become 2. Right, okay, so each subcube can be expressed by a product containing n minus m literals. Each subcube can be expressed by a product containing n minus m literals. For example, how many variables are there? The number of variables here, number of variables in this case is 3. So 1, 2, 3, therefore the value of n is 3. Now if you take this particular subcube, for this particular subcube the value of m is 2, therefore this subcube can be expressed with 3 minus 2, or you can say n minus m literals, That means if you take this subcube, A is changing as well as B is changing. The only thing which is not changing is C. So this complete subcube is representing C. And if you take this subcube, then the size of this subcube is 2, therefore value of m is 1. So this can be expressed by n minus m, or you can say 3 minus 1, which is equal to 2 literals. 3 minus 1, which is equal to 2 literals. So what are those literals? A is not changing. So A complement will be there, as well as B is not changing. Therefore B complement will be there. But C is changing. Okay, so see how we got A complement, B complement is, if you take this particular cell and if you take this particular cell, then this cell is representing 0, 1, 1, or you can say A complement BC, and this cell is representing A complement B, C complement. So if you make a subcube like this and if you add them, then this will become, you can take A complement B as common, so inside we will be having C plus C complement, which is equal to A complement B. So sorry, this is A complement B, not A complement B complement, this is A complement B. So this subcube is only representing A complement B. This subcube is representing only C, because C is not changing. So if you make even a bigger subcube, you eliminate the variables which are changing, and those variables which are not changing, you can write it like this also. Okay, so this is how you can solve, you can minimize this particular expression. So what is the solution for this? This subcube can be represented by C, this subcube can be represented by A complement B. So therefore this complete expression can be written as A complement B plus C. This can be represented by A complement B plus C. Okay, so let me take one more example and then we'll discuss about more properties of K-maps.